Okay, this is 13.3. This is inverse trig functions. Okay, so I know it says think about your unit circle, but you probably actually have your unit circle, at least I hope you do. So if you're trying to find all the places where the cosine of an angle is 1/2, okay, well, cosine is positive in both the first and the fourth, right? So there's a spot here and a spot here where you have an x value of 1/2. Here it's pi over 3 or 60 degrees. Here it's 5 pi over 3 or 300 degrees. Okay? Now, how is that different when you use your calculator? Okay, so if you break out your calculator and you do cosine to the 1/2, or excuse me, the inverse cosine, that's what I'm trying to say, the inverse cosine of 1/2, your calculator is only going to tell you this answer. It does not have a way to tell you two answers, right? It's just kind of the limitations of a calculator. It can only tell you one answer at a time. So what it's doing is it gives you what's called the principal values, okay? Which means that if you are trying to find the inverse trig function or the inverse sine function, or right, you're going to be in particular quadrants. Okay, so for tangent and sine, and you're going to probably want to write this down or print this out. For tangent and sine, you can only be in these two quadrants, and you're not allowed to go through these two quadrants, which means if you have an answer that you expect to be in the fourth quadrant, you have to start here and go this way. It'll be a negative angle answer. All right, and then cosine is only in quadrants 1 and 2. You will never be going through quadrants 3 and 4. All right, so let's scoot this up. Let's try another one. You may see this notation. It's not as common, but I just don't want you to be thrown off if you do see it. Okay, so this is saying, let's find an angle, right? Let's find an angle within the correct quadrants, right? And for sine, I'm allowed to look here and here, all right, that has a sine value of 1/2. Now, sine is positive up top and negative down below, so I already know I'm not looking here, right? So the principal value, when I go to find a y value that is 1/2 within this quadrant, that is pi over 6, right? Or 30 degrees. I would prefer the radians though. Okay, let's try another example. Okay, so tangent of x equals 1. Okay, so first thing, where am I allowed to look, right? Because tangent, I can only look in these two quadrants. And tangent is positive only in the first. Okay, so if I'm only looking in the first quadrant, and I know that tangent is actually y over x, I'm looking for some location where the y and the x values are exactly the same, which happens at pi over 4. Okay, so now these are getting slightly more complicated. Let's just temporarily, okay, temporarily, in fact, let me see if I can change this for you just for a sec. I'm not sure if I can, but I'll try. Oh, I can, look at that. If that wasn't there, okay, if that wasn't there, and I just asked you, hey, what is the cosine of pi over 3? You would say 1/2. Okay, so now let's put that back in, right? So now this problem says, what is, oh, that is way too thin. Hold on, I screwed that up. Here we go. What is the inverse sine of 1/2? In other words, all right, based on the quadrants I'm allowed to look in, which is this one and this one, where do I have a sine value that is 1/2? That happens up in the first quadrant at pi over 6. Okay, this problem is asking, where is there a sine value that's negative rad 2 over 2? Sorry, I forgot to change it to a pen. Here we go. So on the unit circle, I'm only allowed to look for sine values in the first and the fourth. Sine is negative down here, right? And I can see, again, on my unit circle, there's a spot. It's right here. Now, if you tell me that the answer is 7 pi over 4, I have to mark that wrong. No partial credit, no nothing. And the reason is that you have started, let me switch colors. You have started here and you've gone all the way around to get to that dot when you're not allowed to go through these quadrants, right? You have to start, and I'm going to switch colors one more time. You have to start here and get to that spot this way. So the answer is negative pi over 4. Okay, again, really important on the sines and the tangents that you give me negative angles for quadrant 4. Okay, so again, for this example, temporarily ignore this sign and just deal with the stuff that's inside the the parentheses. Okay, so the arc cosine of 1/2, meaning an angle that has a cosine value of 1/2, which is pi over 3. And then we want the sine of pi over 3, which is rad 3 over 2. Okay, scooting it up. Not too many examples left. 3 examples, I think. Okay, so this, I'm not really good at inverse secant, so I'm going to rewrite this in terms of its co-function. This is the exact same thing as the inverse cosine of 1/2. Right? I took the reciprocal of this and the reciprocal of this. Okay, so now I can definitely answer this question. I know there's an angle that has a cosine of 1/2. It's in the first quadrant. It's at pi over 3. Okay, again, sort of ignore the stuff that's on the outside. Let's just deal with the stuff that's on the inside. So the sine of pi is 0. So now I just need to do the arc cosine of 0. In other words, where is there an angle that has a cosine value of 0? And it's way up at the top of the circle, right? Right here, this ordered pair is 0, 1. That location is named pi over 2. Okay, and then this is sort of the situation when you're not on the unit circle, right? You can look and look and look and look and look, and you're not going to find any sine values of 24 over 25 on the unit circle. Okay, doesn't mean you can't do this problem. It just means you're going to have to draw a picture. Okay, so let's take the tangent and then let's draw a picture of this angle. This represents an angle. Okay, so I'm looking for an angle that has a sine value of 24 over 25. Now keep in mind, for sine, I can only look here or here. And since this is positive, I'm not looking here. So that's why I'm drawing a triangle here in the first quadrant. Okay? And what do I know about this angle? I know it has a sine of 24/25, or the opposite side is 24, and the hypotenuse is 25. Okay, so again, arc sine means you're looking for an angle. Well, looky there, I found it. I found the angle. Now I need to take the tangent of this exact same angle. But tangent is opposite over adjacent, and I am missing this adjacent side. Right? I'm trying to sort of make that bold for you. Now, if you did the Pythagorean theorem, you'll figure out that this side is 7, and the tangent of that angle is 24 over 7.